Hello, Assalamu alaikum. Can you hear me?
Walaikum Salam. Ali, can you hear me?
Ji, I can hear you.
Okay. Um, Ali, what's the position? You have a test tomorrow.
I did some questions of momentum, like also of linear momentum and conservation. And then I did some questions of work power energy. There
Very
were
good.
some graph questions in the momentum, like quite challenging. I wasn't able to like attempt those.
Okay. And did you uh, did you try to do some MCQs also?
No, not the MCQs. I did the structured questions of the PC.
Okay. And MCQs are coming tomorrow.
No, he gives like very little MCQs, like 2 or 3 at max.
And mainly he focuses on paper two.
Yes.
Okay. So now we can say here that we have you said you have done questions and you got some answers this time, or
It
some
was
questions?
better this time. Like
Mhm.
I was able to attempt more. Like when I kept on doing the questions, I was after like the fourth or fifth question, I was able to do the
This
rest.
is the thing I told you, that past papers have their own temperament, and whenever you do past paper questions, they always give you a temperament. Now, this is a question which is on dynamics, and it starts. Dynamics means mainly two topics, right? Apart from 2D momentum, dynamics is manageable. 2D momentum is really very challenging. And did you see any of the videos or any source material I have sent you? Could you do that?
I had seen them before on dynamics.
Okay, that's good. So tomorrow you have 2 chapters. If we test them, if we try our work here, and you can ask me any question. The first question is define force. What is the definition of force? Force is the rate of change of momentum. What is force? Force is the
Hello, sorry, sir. I'm Ali's father. I'm just. Is it okay if I take a couple of your minutes?
yes, I'm hearing. Please go ahead.
Yes, you're doing like pretty hard work with Ali. We are really impressed. Is just that he's not able to crack questions when he sits in tests these days. So what I've discussed with Ali is, although he's trying to practice as well, but when they are straightforward simple questions like basic formula like applications, then he's okay. But when the teacher, he rephrases the questions, or makes it a bit difficult, he gets no clue. And this is alarming, since very kindly you've been sending that the examination timesheet, like only 3 months are left, or 90 days.
Right.
Unfortunately, Ali is not able to gain that confidence. So it's a bit worrisome for me. Is there something you can figure out, or you want us to do? Because I'm clueless here, how to get him going, and I'm starting to now get worried.
Actually, very frankly, the thing is simple. In A level, the questions are really hard. And I tell you very confidently that no teacher actually rephrase the question. You can see the screen. This is the question, right? So all teachers in A level uses the same past paper, and your worry is perfectly right. Even I have the same worry for actually many of my students, because in A level, a lot of students face the same problem. The solution is very simple, which Ali is now following, and he has to follow the same solution. Whatever you do in A level, it actually moves around the past paper. So what you do is a simple solution which everyone has to follow, not only Ali. The solution is simple. You have to finish one chapter and you have to do topical past paper. Now see, this is a chapter which Ali is going to face tomorrow. This is the topic dynamics. So now it actually depends on a simple rule. if dynamics is there, you can see the question number here is 45. So you can imagine in one topic, there are 45 questions. So this is paper 2 questions. So Ali has to start doing, Ali now have the books also. And he has to do questions with me. He has to, we have 2 extra classes every week for past paper only. Similarly, he can do some questions in college with the teacher, some questions on his own. This is actually a simple solution which I'm now writing on the screen. The solution is topical past papers. There is no magic, no special rule, no special clue, nothing. Only one rule. Take a topic, do its topical past papers, paper 1, paper 2, and then after doing 20-25 questions, you will see the change. Before that, no change can occur. Theory is very simple, but questions are very hard. This is the simple way to improve. And I have started his test also. You can monitor his performance there. This is the only thing which parents have to do. And obviously they can do the same thing. They just have to keep a track of his performance at his tuition, at his college. The main work has to be done by teacher and the student. And the rule is very simple, that the student and teacher have to work on topical past paper. This is a simple rule.
Yes, but sir, the thing is, I totally understand and agree, and I validate your point. The thing is, when he's sitting, you like, well, so primarily when he tries to attend the question, you like, he gets stuck in like the simplest of ones. Yes, he gets through, but a bit of complication, you like, he starts voiding, and when he starts voiding, he just gives it up. And if he doesn't know how to solve 25, let's say out of 25, he solves just 2 or 3, then how do you expect him to complete 23 without your interference, right?
No, this is the same thing I said, no? That there are 45 questions, right, in one topic, and there are around 12 chapters in the syllabus, 12 chapters. So it's a working way in the college, in the tuition, between the friends, on the YouTube. There's a lot of resources now. This is not the way the teacher, or no teacher can do all the questions with the student, and even no student can do all the questions himself. I can assure you that I'm teaching in different colleges also. There is no one who can do these questions alone. So people work together, work with the tuition teacher, work with the college teacher, then you can crack them. Otherwise, no one can expect all the questions with the student and all the questions with the teacher even. Because obviously, if we do one question and if we do all the question, even then obviously in 1 month we can do only the one topic. So there is another problem with the time constraint. So it's a midway that if there are 45 questions, you have to do as much as you can. You have to mark down the queries, ask the teacher, and move forward. Actually, growth is needed, which is very important. After doing one question, 2 questions, CI provides examiner reports, marking scheme. So growth is always there. So once you do a topic, you have to do it all. You have to do all the questions. Some questions with yourself, some questions with the teacher, some with the college teacher, even some with the friends. This is the only way in which A-level works actually.
Right. Okay, so because you like, it was pretty dejectory to see him, you like, he just got less than even 50%, around 40% in his test, and
Yes,
he
I
was,
know.
yeah,
He
so
told me.
yeah.
Perfect. I totally agree with your concern.
Okay. So I'll leave him with you. You like, I'll monitor his performance. His teacher, as he says at school, you like, is maybe this is how it happens in school. They don't have that much time. It's
Hmm.
spread, like some are serious, some are not very serious. So he's pretty much on his own and with you. So
Hani, but in college, I'm sorry for cutting the point, but I assure you that in colleges you will always find some serious, and you can find some time in the library. And I tell you very frankly that this is the only way actually, because it's a huge syllabus, and you can imagine O level was of 3 years, and AS level is hardly of 7 months, and people start in September, and March is the ending. And obviously, after March, 1 month is left. I will try my best and I will keep on in touch with you. And inshallah, I'm also obviously monitoring his performance, and I hope that he will improve, inshallah.
thank you so much. Really appreciate your help.
No problem. I'll always welcome. Okay, Ali, what's the definition of force? What we were discussing?
It was the rate of change of momentum.
It was the rate of change of momentum. A ball falls vertically downwards towards a horizontal floor and then rebounds along its original path as illustrated. The ball reaches the floor with the speed 3.8. The ball is then in contact with the floor for a time of 0.081 second before leaving it with the speed 1.7. The mass of the ball is 0.062. Calculate the loss of kinetic energy of the ball during the collision. So you have to see the data, you have to see the working. And you know the formula of change in kinetic energy.
I have done this question.
Oh,
Like I've done till 2019, like a question report.
okay. You have done this question. And what about this question? If you look at this one.
No, I haven't done this one.
So let's try that. That's good. A cylinder is suspended from the end of a spring. The cylinder is stationary in water with the axis of the cylinder vertical. The cylinder has weight 0.84 Newton, height h, and a circular cross section of diameter 0.031 meter. The density of water is this. The difference between the pressure on the top and bottom faces of the cylinder is 520. Do you remember this topic? It is called upthrust. This is a rare topic. It comes very less, and that is why it becomes a problem. It is not one of those very common chapters, but I'm not sure that is it coming, because I think it's part of forces. Um, he has done, I know your teacher has done this, but I doubt this topic can come because upthrust is actually part of forces. Do you remember upthrust in your class? Have they done that, right?
Uh, it was the resistance against the downward motion in a liquid
Yes, it's a
fluid.
type of upward force, but I think teacher knows that upthrust is not part of dynamics. He clearly says dynamics and work energy power. Am I right?
Yes,
Okay, then try this. Now look at this question, the kite one. Have you done that?
not this one.
Okay, state Newton's first law of motion.
That an object will remain in at a state of rest or motion unless a resultant force is applied.
Very good. A square is pulled in a straight line along horizontal ground by a wire attached to a kite as shown. The mass of the square is 89 kg. The wire is at an angle of 28 degree to the horizontal. The variation with time t of the velocity of the square is shown on the figure. Now you can see this is the velocity and time graph. And you can see it's type of a parachute. It's a big kite and it is being inclined on an angle of 28 degree. Use figure 2.2 to determine the distance moved by the sphere from 0 till 5. You know, velocity time graph and distance moved. How we get that?
Area under graph.
Very good. So I shade the area and you have to help me to find it is June 20 and it's this one, and you have to find the area for me.
So I can make it a triangle and a square and then solve it.
Perfect. You can make a trapezium. You can make a trapezium. I can double shade it. This is a trapezium. Trapezium plus triangle, whatever you like, it's your choice, because examiners have no problem. You can make a triangle, and I do what you said, that I can make a triangle. Look, this is a triangle. This is a, so I have A3, A1, and A2. Have you tried it?
The answer is 17.2 meter I'm getting.
Okay, we can check it. You have, I think that can't be wrong. I don't have access right now. This is June 2023. Okay, we can check it, but you have made a triangle, rectangle, and a rectangle, right?
Yes.
Okay. Use figure 2.2 to show that acceleration of the sphere is 0.8 at time 2. How we find acceleration? How we find acceleration from a distance time graph?
The gradient. The
Sorry,
answer
velocity. Yes, you're
getting
right. Velocity and graph, we find the gradient. So he's asking for 2. This is the point. This is another point. So I can take any number which suits me because it's a straight line. So I can do up to here. So I can take this as a triangle and y upon x. Gradient is y upon x.
the answer behind the book of the first part is coming as 18.
And what you are getting?
I'm getting 17.2.
So a minor error is coming. You can check. Are you checking from your past paper book?
Yes.
Okay. So then there must be a marking scheme type thing, right?
Yes. The first I took half into 2 into 2.4.
Half into 2. Half into 3 should be there. Na? The base is 3.
Okay, that must be the mistake.
Half into 3, the triangle you're talking about, right? Half into 3 into 2.4. Height is 2.4. The base is 3 and
Now I'm getting 18.
okay. And now you find the gradient. This is the working for the gradient.
I got the same. 0.8.
Good. So we got the acceleration. And now the tension in the wire at time t is equal to 2 is 240 Newton. Calculate the horizontal component of the tension. How we find horizontal and vertical component? Tension in the wire is 240. We come to this diagram. He says tension is 240 Newton and we resolve it. So this is 240 cos 240 cos 28 and 240 sine 28. Do you remember this resolution thing?
Yes, in the kind dynamics chapter we did it.
Yes, we did this thing. This is actually a resolution thing. Every inclined vector has two components, horizontal and vertical component. 240 cos 28 and 240 sine 28. Now he's asking for, in the question, he is asking for horizontal component. So this is the horizontal component. So you show a small working. You say 240 cos 28. Now solve that.
It's 211.9.
Right. The total resistive force acting on the sphere in the horizontal direction. Now we have to come back here and we can see he is talking about at time t2. This is the position, right? At time 2, which is a very important concept in past paper, that all parts are mutually connected. You can see it was 2 seconds and you can see it's also 2 seconds. So they are mutually connected. It means the acceleration you have will be useful here. How we find a situation, how we tackle a situation here, because, sorry, the wire is at an angle of 28. The variation with time t of velocity of the sphere, he is being pulled by the kite. So what we know about a resultant force, we have a concept. Resultant force is equal to greater force minus smaller force, which is MA. MA is equal to greater force minus smaller force. Now you have this formula. You have the sphere mass, which is 89 kg, which I put here, and I have the acceleration 0.8. What was the greater force? Now you see this force is driving it. So this is the greater force. What force you got for that? The horizontal component?
211.9.
211.9. And we have smaller force. The smaller force is the opposing force. It is the total resistive force. So if the sphere is going to the right, this is the direction, it must be facing a resistive force X. So I put the X here in my equation, which I need to find. Now you solve this to get the answer.
I'm getting 140.7.
You can check in the same book.
Yes, it is also giving 140.
Good. So you got this resultant force concept here. Now we come this part. The sphere is now lifted upward by a gust of wind. Now it is in air. The guy is in the air. For a few seconds, the sky moves horizontally through the air with the wire at an angle of 45 to horizontal as shown. By considering the vertical component of the forces acting on the sky, determine the new tension in the wire when the sky is moving horizontally through the air. Now we have to see this working, that this is the tension as usual, and a component will come here, T cos 45, and one component will come here, T sine 45. The downward force will be weight, and the object is going upward. Now this part I have explained here. The sky is now lifted upward by a gust of wind. For a few seconds, the sky moves horizontally through the air with the wire at an angle of 45 degree. It's moving horizontally, and this is the word to be specially understood, that even though he is in air, he is moving horizontally. So I make a correction in my diagram. It's not moving upward. He is presently moving horizontally. Now, when it is moving horizontally, it means the upward force and the downward force would be equal, because otherwise it would be moving up or down. So now you have this equation. And what you need to find here now, you need to find the tension.
I am getting 1234.
1234, and you can round it to become 1200 Newton. So you can check it.
The answer is also 1200 Newton.
So that's good. So you got this idea from this question. Now let's try a question from, this is projectile, and projectile is not there. It's also projectile. I think projectile can't come because I'm not sure. I'm no idea what your teacher might think, because dynamics is purely dynamics. It is a case now. This is called 2D momentum. This is a question from winter 2019. Did you try this question?
Not this one. I don't have this question in my book.
Now, sorry, can you hear me, Alina?
Yes, I can hear.
A ball X moves along a horizontal frictionless surface and collides with another ball Y as illustrated. Before collision and after collision. This is a topic which is considered to be a dangerous topic of this chapter, and this is called 2D momentum. Ball X has mass 0.300 kg and initial velocity Vx at an angle of 60 degree to line AB. Ball Y has mass 0.200 kg, initial velocity 6 at an angle of 60 degree to line AB. The balls stick together during the collision and then travel along line AB. Do you know stick together means? We were revising this chapter and we use this word coalesces. Coalesces means that two objects collide and they move together. They are coming at an angle. Calculate the 3 significant figure, the component of initial momentum of ball Y, which is perpendicular to line AB. Now we can resolve, and you can see one component here, one component here. This angle would be 60. And we have the mass, and one velocity is 600, and we can resolve the similar way. We can resolve here and we can resolve here, right? For the time being, I delete the x1 because he's asking for for to resolve y. So there are two components. We can see here 600 cos 60 and 600 sine 60. Now, these are the two components. So he says component of the the component of the momentum, initial momentum of ball y, which is perpendicular to the line AB. So he's asking for vertical one. So first you find the component of velocity, and you know what is momentum? Momentum is mass into velocity. So how we find the component of momentum? Momentum is mass into velocity. What is the mass? 0.2 into component of velocity 600. Sorry, 6.00. It is not 600. Let's say 6 only. He's just writing 6.00. So it means it is actually 6. 6 into sine 60. This is the momentum in the vertical direction. So
the perpendicular means to take sine 60.
perpendicular means vertical component. Perpendicular means vertical component. And here the vertical component is 6 sine 60.
It's 1.04.
1.04. 1.04, and the unit is already given. Can you check it if you have this question? It's winter 2019.
I don't have this question in the book.
Coach, do you have the rough paper with you? The
No.
app?
No.
So can you install this app whenever you get free? Rough paper, one of the most famous app for doing past paper.
I might have it on another phone, but I'm doing it on my laptop right now. So
Then it's okay. And okay, we should move forward. The calculation you have done is obviously can be checked later by considering the component of the initial momentum of each ball perpendicular to line AB. Calculate to three significant figure Vx. Now again using the word perpendicular to AB, I have found the component of velocity, component of y, and let's work out for x. I'm rubbing it. Now look at this x. The velocity is not given. I make a resolution here. This is a cut. This is a resolution. This angle is 60, which I'm shading. This is 60. Now it will be Vx cos 60, and this will be Vy sine 60. Did you get it what I did?
the resolution.
Yes, the resolution. Resolution is not simple. Do not consider it simple. It's a very tricky concept. And remember this, whenever you have angle, where the angle is touching, it is the cos component, and where the angle is not there, it is the sine component. Now you see, this is before collision and this is after collision. Now the approach total momentum before collision is equal to total momentum after collision. We are presently working, the examiner is trapping us in a word perpendicular. We are working on perpendicular dimension, the y-axis he means. So when he says perpendicular, he means y-axis component. So now can you let me know, can you tell me that is there any y component after collision, or the object is moving horizontally after that?
It's moving horizontally.
Good, there is no y component. So now you see, I will write M1, the formula M1U1 plus M2U2. Is it the total momentum before collision?
So what is Vx? Won't it be like the one which is the arrow?
Vx is the velocity, na? Vx is the velocity. I have written it. Vx. Acha, oh, I wrote by mistake Vy here. It is Vx on both. Vx is the velocity for the object x. Vx is the velocity for the object x.
Okay. So it will be like the velocity into cos 60.
Yes, velocity into cos 60 and velocity into sine 60. But he is asking to work down for y-axis. So I will take this. I will not take the x component. This is 2D momentum. There are two axes involved. So I'm working with y-axis. And this question now needs the concept of total momentum before collision is equal to total momentum after collision. Now, the very tricky part comes. There is no motion in the vertical axis. So after collision, the y component of momentum is 0. Y-axis coordinate is 0. There is no momentum on y-axis. There is no momentum on y-axis. So what you do, you will make it equal to 0. Why you have made it equal to 0? Because there is no momentum on y-axis after collision. Now start putting the values. What was the momentum before collision? What was the momentum before collision? The object y, we had calculated the momentum 1.04, the total momentum. How we calculate the momentum for object x? Momentum is, what's the formula for momentum? Momentum is equal to mass into
Velocity.
velocity. And what is the velocity we have to take? Vx sine 60. So I will take the mass of, what is the mass of x? 0.3. The mass of the x is 0.3, and a very important steps now comes. I will write minus Vx sine 60 equal to 0. Why minus?
1.04? Why will we add it with the one above, the answer above?
No, we have calculated the momentum, na 1.04. You can calculate it again. You have the data and you calculated this value. Na? This is the momentum of y. This is the perpendicular momentum of y. And I haven't calculated it again, but it will come the same answer, na? Because velocity is 6. Velocity is 6 and component is sine 60. So it will be 0.2, which is the mass of y. 0.2 into 6 sine 60, that will be M1U1, mass into velocity. The same, we are adding the two components. We are adding the momentum of x with the momentum of y. Now, how can, why it is minus? If you consider this component, this is velocity y, it's upward and the above is downward. So if I take it plus, the velocity of x will be minus. See again why the two velocities are plus and minus.
Because of opposite direction.
Because of opposite direction. Now, if we solve it, 1.04 minus 0.3 Vx sine 60 is equal to 0. Now you have to solve this equation to get Vx.
Minus 1.55.
It shouldn't be minus. It should be plus. Why it's coming minus? If I solve it further, 1.04 is equal to 0.3. It goes on the right side.
So instead of Vx, we aren't supposed to put 6 because I put 6.
No, we need to find Vx now. Vx is not 6. Look at here. Vx is not known. You have to find, if you read the question, you have to find Vx. The 6, make it clear. 6 is the velocity of y. It was Vy. Vy is 6, but Vx is unknown. You need to find Vx in this part. Now this is the working.
Now it's 4.
Now it makes sense. Vx is 4. Show that the speed of the two balls after the collision is 2.4. I have to rub this screen. Okay, read the question. Show that the speed of the two balls after the collision is 2.4. You can see here, is it a case of coalescence? And what's the meaning of coalescence?
When the two momentums join together.
When the two objects join together and they're moving horizontally. Let's write down the formula for coalescence first. Then we can see how we can solve it. M1 U1 plus M2 U2 is equal to M1 plus M2 into V. Copy down this formula with me. This is a formula for coalescence.
I copied it.
Okay, now how we apply this formula? As I said, 2D momentum is a very difficult topic and you need to be careful. I hope the teacher won't go for such a difficult question, but anyway, CI is there and every difficult topic should be known, should be marked and should be observed, as we were discussing just a quick time back, that these questions should be marked separately and these are challenging questions. Now the challenge is here that object after collision is moving horizontally. You can see the cleverness here. Now the motion is on horizontal. He has already asked us to solve for y. We have solved for y and we got the value for, and we got the values for this. Now, this is the case. We got the value of Vx. We got the value of Vx as 4. We have the data. Now we have to see the resolution on x-axis because we need to make the coalesces on x-axis. I resolve again. This is the resolution on y. This will be 6 cos 60 and it's here. And I resolve on this here.
Sorry, I had a bit of an internet issue. I wasn't able to hear you. Now I fixed it.
Are you able to hear me now? I have just started the you were with me in this part. You had made the equation, right?
Yes, I had made the equation.
Now I'm solving for x-axis because after coalesces, the object is moving on x-axis. I'm resolving again for clarity of the diagram because the diagram was quite smudged. So I'm making it again. And Vx was 4. Remember that the Vx value is 4. So I will write here 4 cos 60 and here it is 4 sin 60. Here it is 6 cos 60 and 6 sin 60. See the resolution.
Okay, with Vx we put 4 and Vy is 6.
Yes. Now you see I'm putting a tick. You can see these are the two arrows of the horizontal component. Are they in the same direction? The two arrows.
They're in the same direction.
Okay. Now I put the formula. What's the mass of X? See the data. What's the mass of X? 0.3. And what is the mass of Y?
0.2.
Good. Now we proceed with the formula. X is 0.3. So I will write 0.3 4 cos 60 plus 0.2, which is the mass, 6 cos 60. You can see the working. This one. You have to see the data I have inserted.
So this will be equal to the M1 plus M2.
Yes.
V.
Now we move and put the values. 0.3 plus 0.2 into V. Now, a careful calculation is needed. You try it. I'm just coming. You solve this equation to get V for me. Ali, have you solved it?
I'm getting 2.4 meter per second.
Two point
4.
2.4. I think it looks right. Anyways, you got the concept. Calculation can be rechecked. And now this part is from deformation. You can see the formula, Hooke's law. Now, sometimes it happens when teacher give the exam questions, they get up type of merger, and sometimes questions come in this way. Again, I'm not sure what your teacher will do, because he can give a question like that. The two balls continue moving together along the horizontal frictionless surface towards a spring as illustrated. The balls hit the spring and remain stuck together as they decelerate to rest. All the kinetic energy of the ball is converted into elastic potential energy of the spring, stored in the spring, where K is the spring constant of the spring and X is the compression. The spring obeys Hooke's law and has a spring constant of 72. Determine the maximum compression of the spring caused by the two balls. Now, how we get the kinetic energy when we have the velocity?
Half mv square.
Yes, half mv square is there. The spring constant is given. Ball, the total mass is 0.3. All the kinetic, this balls hit the spring. Now, how we manage this 2.4? How this 2. Did you get the answer 2.4 in your previous part?
Yes.
This is the same 2.4. He says frictionless. It means no loss of energy will occur. He says the NX is compression and the caused by the two balls. Now compression will be X because X is the extension. So converted into elastic potential energy. So you can say this E is the kinetic energy. E is equal to half mv square. And what is the value of K? K is 72. And we need to find X. Now you have the data. You have to solve it. And I'm just coming, solve it. Sorry for keep you waiting. Have you solved for x?
Yes, I got 0.2 meter.
0.2 meter. It looks fine. Did you underroot in the end?
Yes.
There is a square on x, right?
Yes, I did under root of 0.04. Then I got 0.2.
Okay, good. Sketch graphs to show the variation with compression x of the spring from 0 to maximum compression, the magnitude of deceleration of the ball and the kinetic energy of the ball. Sketch part is always very challenging. And you have to see the variation acceleration. If we suppose that kinetic energy is constant and we have acceleration versus displacement, acceleration may be a constant value. And what about kinetic energy? You can see that kinetic energy will be decreasing or increasing.
It will
When an
decrease.
object is very good, decrease, because object is going to stop, right? So it will be a decreasing line. The line will be coming down. And what about the acceleration?
It will increase.
It will be a deceleration, right? The magnitude, he has used the word magnitude. So acceleration would be constant because the force is constant. So acceleration would be constant and kinetic energy will decrease. Got it?
Why will the deceleration be constant?
Because it's coming to rest, and acceleration means decrease in velocity. Velocity is decreasing at a constant rate. Remember, acceleration is the change in velocity. So suppose you were at 2.4, you come to 1.4, then you come to 1, and you come to 0. Velocity will decrease, but acceleration is the change in velocity. It can remain constant because it says decelerate to rest, and it's a case of frictionless. There is no friction, only the spring is stopping the object. So we did this. And what about work, power, energy? Did you did some work on that chapter?
Yes, I did. Of the potential energy and kinetic
Yes,
energy.
kinetic energy, power, efficiency.
Yes. Yeah.
Okay, good.
The power one was confusing where we had to find the electrical power. So that was
Electric power has the formula which you have studied in your current chapter with me, which I had sent you the list, the formula list for chapter current. So that chapter, the power, electrical power is always, the formula is work upon time in standard, but it's VI, electric power. Electric power is voltage into current. Now, the first question I found here, it's work, energy, power, and deformation. It's a mixed question. This is again deformation with the power. These are mixing questions. Now we can try this question. If you haven't done it before, you have to see the question, see the diagram. If you have done it, then we can try some other question.
maybe I don't remember if I did it.
So are you marking on your book if you are doing a question, or you are doing from any digital file yet? First,
First, I did these ones from the book and I did it on the register, and now I'm doing it on the book.
Good, because whenever whenever you do a question, you should always mark it. So do you have a record so that you don't do one question again and it will be time saving? So remember to you keep one book and keep on marking it. State what is meant by work done. So what is the definition of work done?
Force into displacement.
Work is the product of the force and the displacement in the direction of the force. Work is the product. Work is the product of the force and the displacement in the direction of the. Remember to say direction in the force. It's necessary. A lift elevator of weight 13 kilonewton is connected by a cable to a motor as shown. The lift is pulled up a vertical shaft by the cable. A constant frictional force of 2 kilonewton acts on the lift when it is moving. The variation with time t of the speed v of the lift shown. This is a graph. Graphs are always tricky. You can see the line is going up, then the line becomes horizontal, and then the line comes down. Can you find this question in your book? So you can write in the book with me, and you have a question in front of you. If you can find this question there in the book.
I'll try finding it.
Okay, you can let me know.
Oh, this is work power energy.
Yes, this is work energy power. The definition we have done, and we have to do the second part.
I'm just finding it, but I'm only able to find the previous questions about the spring in this chapter.
November 1923. You can check the year reference. No problem. If we do not find it, then we solve it on the screen.
Yes, maybe they have given it on some other like chapter.
This is a common issue. They may be because it involves dynamics, it involves kinematics. So it's possible that they have given it in dynamics or some other chapter. Let's start there. No problem. You have this graph in front of you. Use figure 2.2 to determine acceleration of the lift between 0 and 3. If you see here, 0 and 3. It's a speed time graph. So the acceleration will be the gradient will be equal to y upon x. Now, can you help to find the acceleration?
Can I also take the point of 0, 0?
Yes, surely. It's simple. The x will be 3 and y will be this. Y is 2.4.
It's 0.8 meter per second square.
0.8. Okay, right. Looks fine. Now, the work done by the motor to raise the lift between 3 and 6. How we find the work done? Work done, as you said, work is the product of force into
The
displacement. Now, from 3 to 6, if you come here, from 3 to 6, can you see it's a straight line?
Yes.
Straight line means velocity is
Constant.
velocity is constant. Straight line means velocity is constant.
So the
Now
displacement will
you see the word lift, raise. This is the word which gives you a clue that when it is being raised, it is potential energy is equal to mgh. It means work done will be the potential energy change. So I will use this formula. Velocity is constant, so there is no change in kinetic energy. Now, see the mass. A constant frictional force is there, and we have to see if we have the mass. Yes, we have the weight. This is the weight. 13 kilonewton. So how can we solve it if we have the weight is 13 kilonewton and then we need the height.
So we'll find it by area under the graph.
Yes, very good. 13 I will replace for mg, and we need to find, I don't have the height, and as you said, it is the distance. This is the region and this is the height.
Is coming as 7.2 meters.
7.2, yes.
So we'll convert the kilonewton into Newton, like 13,000 Newton.
Yes, you have to do that. Perfect. It's 13 or 13.2. What it was? It's 13 kilonewton. You're right. So $13 into 1,000 into 7.2.
It is coming as 9.36 into 10 power 4.
It looks fine. I'm just looking at the next part now. The motor has an efficiency of 67%. The tension in the cable is this much at time 2.5. The input power to the motor at this time. We have to see 2.5. What is 2.5? Oh, 2.5 is here.
I don't understand such questions like about the efficiency. I'm not able to do. Even in that quiz you sent on the Google Classroom, it was like I didn't attempt those.
Good. This is a good question because efficiency questions are not difficult for you. Actually, it's difficult for everyone. Efficiency formula is very simple, and you can always write down the formula first. It's power output upon power. Always start with the formula. And he says percentage efficiency. So I will write here 100. What is the percentage given? 67. So I will write 67. I will write power input, let's say PI, power output into 100. Now this is the situation. Whenever you come across a question on efficiency, remember to do these steps first. It will give you a good start. The examiner will see some steps, which I always prefer. And also you can see here, you can work out some missing values now. Now you can see here, what is the power? He says determine the input power. It means, do I need to find the numerator?
Yes.
Good. You got the point. Then it means first I should have to find what?
So will it be flipped like the power output or power in it was in the formula?
No, it will be flipped later once because we first need to find power output. Actually, we need to find power input. But in order to find power input, what power should I first need to find?
The power output.
Yes, now you read the point. This is where the efficiency questions are difficult because you people do not write down the formula, do not search the actual variable to find. You can't find efficiency or you can't find the missing variable directly. And this is obviously a difficult question. So you need to find power output. Now, how I can find the power output? I did this question again. He says, tension in the cable is 1.6 times 10 power 4 and the time is 2.5. You can look here now. This is the position of 2.5. This is 2.5. And I go up. This is 2.5. Now at 2.5, can you find the velocity? What is the velocity at 2.5?
2 meters per second.
Now here the difficult part comes. Now you have to think this is the lift. This is the weight. This is the upward force, which is tension. And the lift is going upward. Right? The lift is going upward. This is the upward force, tension. And the downward force is W. And I think we had some friction also. Let me check what was the friction. Look, there is a constant friction. How much is the friction?
2 kilonewton.
2 kilonewton, right? Friction is 2 kilonewton. Now the lift is going upward with an acceleration position, and this is the point where velocity is 2. Okay, so now this is the position. Now, where should I add the friction?
On the output?
No.
On the input.
Lift is going upward. He says that a constant frictional force of 2 kilonewton acts on the lift when it is moving. Friction always opposes the motion. So where the friction should come now?
On the tension?
On the?
So it will oppose the motion, so it will be more tension.
It will be in direction of tension or it will be opposing the tension. The object is going upward.
So it will be downwards.
Yes, it will be downward. Good. So we are now in a complete picture. We already have calculated the work done by the motor to lift between 3 and 6. We know this. We have this acceleration of the lift, and now we have this position. Now I'm here. I have to think how I can find the power. If somehow I can work out the power, I need to find the power. Power is work upon time. You know, there are two formulas for power in this chapter. One formula, power is equal to work upon time, and the second formula, power is equal to FV.
Yes, from the derivation we got this one, right?
Yes. Now, this is the point. Now, you have to help me. I have done up to here. And now I need to find power output. I have everything in my hand now. And I have the data. I have a diagram, tension, friction, weight, and I have the value of tension also.
So we will add all of these to get the power input.
No, you can't add them. They are not in the same direction. Vectors can be added only when they are in the same direction. They're not, all of them are not in the same direction. So you have to think, and 1 minute you can take, and you can now think that the formulas, because this is the most difficult part of the question.
I don't understand. What am I supposed to do?
There are two formulas. There are two formulas.
So we'll use the second formula and take 2 as the velocity.
This is a good idea. And what about the force? What we should take for the force?
The mg.
No, but you have a tension in your hand. I have underlined why you're not considering the tension, the force which is pulling it up. And you have a friction issue also.
So we'll subtract the tension by the resistance it has, as they are in the opposite direction.
Okay. And formula is P is equal to FV. Tension is 1.6 into 10 is to power 4. You can put the formula for that and you can find the power. The velocity you got correct. Velocity is how much? As you said, velocity is how much?
It's 2 meters.
Good. Velocity is 2 and we have a tension here. Tension will be the force which is pulling it upward. So tension will become the force. Find the power now. Force into velocity.
So we won't subtract the tension by the friction.
No, tension is in the it's being pulled upward. It's being pulled upward. Friction and weight are added and they are equating the tension. That's why rope is not breaking. This is the force and the velocity.
30,000.
Now you have the output power. Now what you have to do, you have to put it in the formula to find the input power. The main question was input power.
Is coming like as 47,761.
41.
47,761.
Can you convert it into scientific notation for it's good for us?
4.7 into 10 power 4.
Then it should be correct. Then it looks fine. State and explain, last part, whether the increase in gravitational potential energy of the lift from the time 0 till 7 is less than, the same, or greater than the work done by the motor. This is a straightforward question because you should understand this whether the gravitational potential energy from 0 till 7. This is the whole journey. 0 till 7, the velocity increases, velocity becomes constant, and then velocity decreases. Okay, there is a share of kinetic energy. From 0 till 7 is less than, the same, or greater than the work done by the motor. The work done by the motor, is it all converted into gravitational potential, or some work is done for other things?
So some work is also done against the resistance.
Very good. So if some work is done some of the work is done against the 2 kilonewton friction, will the gravitational EP will be less than the work done by the motor?
Yes, it will be less.
So the answer is simple. Motor is doing some work. Some of the work is gone into gravitational EP, and some of the work is gone into work done against friction. So gravitational EP will be less than the work done. Have you revised all the formulas for these two chapters?
Yes, I have.
Because the formulas are very important. Remember, I had sent you a list for work, energy, power formulas, I think.
Yes, I have also written them.
Okay, that's very good. So that's good. Then let's after this class, you should sit and revise the definitions, and it's better if you make some quick revision of. You can try 1 or 2 questions also yourself, and let's hope for the best. Let's see what happens tomorrow. Okay.
Okay.
Okay,
Allah.
Ali. Allah Hafiz. If you have a query after the class, you can send me a picture on WhatsApp, right?
Okay, I will do that.
Okay, thank you. Bye.